Hello everyone, welcome to reInvent. My name is Mohsen Ansari. I'm a solution builder in AWS, and today I'm going to talk about architectural best practices for machine learning applications. So the outline of this presentation is going to be, at first we're going to talk about taking regular software applications from development environment to production, and then we're going to focus on taking and comparing that to taking machine learning applications from development to environment, from development environment to production environment, and then we're going to talk about how are we going to design a well-architected architecture, and then at the end we're going to talk about building intelligent applications on AWS using some examples. So here, when I refer to intelligent applications, I mean any application that has some component of AI or ML inside of it. So when you want to build a software application and take them from development environment to production, you usually go through 5 main steps. First, you need to write your application in the development phase, and then you need to build it, and then you need to test it, and once the testing is done, you deploy it on the servers, and then you serve that application to the users, and then the users can use it. Now, comparing that to machine learning applications have a little bit more steps and more nuances and details into it. So for example, in the beginning, you have the data ingestion and data pre-processing. And then after the data is ready to be used, then your machine learning engineers need to build the features or the model inside of your machine learning applications. And then once the model is ready and the data is ready, then you need to train the model with the data that was provided. And then once the model is trained, what you can do is that you need to evaluate the model to make sure that it's accurate enough. And sometimes you need to tune the parameters that you use for machine learning, for training your machine learning model. And then after the model evaluation, you can deploy it onto the servers, and then your users can use it. And the using of that machine learning model, we call it inference. So they can send inference requests to your machine learning model. But the difference, one of the main differences between this and the regular software applications is that even after the machine learning model is deployed and the users are using it, you may need to go back and retrain your model, and you need to continuously monitor the performance of your model. And the reason for that is because the data that was coming to your machine learning model might be outdated after a while, and then the trends of the data that is coming to your model right now might be not the same data that you use for training your model. So you need to continuously, every once in a while, retrain your model so that it's always up to date and it's not using an outdated set of data. Now, if you want to build a machine learning application on AWS, we have a wide range of services, and we categorize them into 3 different tiers. So in the top tier, as you can see, is an AI services, what we call. So in these AI services, they have ready-to-use APIs so that you don't need to worry about building a model, training, or the infrastructure that is running under the underlying infrastructure that is running these models. All you need to do is to provide your request data and then send the request to these APIs and then get the response out of it. But if you want more customization and more freedom onto the model that you're building, you can use the middle tier, the machine learning services, and you can build a custom model there and then use your own model instead of the AI services that are provided. But then we can go one level further, and if you want to have the complete freedom over the infrastructure that is used, and you want to maintain the infrastructure yourself, you need to configure the infrastructure yourself, as well as building your model. You can use the lower tier services that are listed in this slide, but that if you use everything with the complete freedom, then you need to make sure that the security of the infrastructure is intact, and you need to maintain the infrastructure and sometimes patch or take care of it essentially. Now, doesn't matter what your use case is. AWS AI ML services have something for you so that you can use to build your machine learning applications. Now let's talk about how are we going to build a well-architected applications on AWS. So by well architecting, I mean AWS has a tool that's called Well-Architected Framework. And with this tool, you can make sure that the architecture design that you have is well architected and is following the best practices. And these best practices that I mentioned, they're in 5 different contexts. As you can see there, these 5 different contexts, we call them the 5 pillars of the well-architected framework. The 5 pillars are operational excellence, security, reliability, performance efficiency, and cost optimization. As an example, in the security pillar of the well-architected framework, makes sure that you're following all the security best practices when you're designing your architecture. To give more onto the examples, the well-architected framework has different set of lenses, what we call lens of the well-architected framework. So the well-architected framework has different sets of lenses. For example, it has serverless lens, and now we're using an example of machine learning lens. What a lens does is that it ensures that you're following the best practices of the well-architected framework in the context of machine learning in this case. So as you can see in the table in this slide, in each of these pillars that we mentioned earlier, there are some best practices from the machine learning lens that are mentioned. For example, in the cost optimization, we're saying a best practice is to use managed services to reduce your cost. We'll go into the details of each of these best practices later on with the examples. So now let's go and see how are we going to build an intelligent machine learning application on AWS. So I'm going to go through 2 different examples. The first one that we have is called improving forecast accuracy with machine learning. So improving forecast accuracy with machine learning is a solution implementation that we have built in AWS. That what it does is that you give a set of historical data to it, and then as the output of the solution, it gives you the predictions of what the trend of the data will be in the future. For example, in this diagram that you can see, one of our customers, App8, is putting the data that they have, the historical data of their customers over time. And then, so those are the solid lines, solid blue lines that you can see here. But then the dashed lines in this diagram are the predictions that this solution, improving forecast accuracy, the solution has made for us, that now App8, a customer of AWS, can see what is the trend of their customer over time going to be, and then the high and low level of confidence, so they can make sure that their customer trend is going to look something in between the high level and low level of confidence. So this is one of the examples that we're going to explore, and we're going to see how we made decisions around making sure that this solution is designed with best practices in terms of architecture. So let's take a look at the architecture diagram of this solution. In the architecture diagram on the left-hand side, you can see the customer puts the data that they want to make a forecast to it into an S3, Amazon S3 bucket. And then once the data is provided in the middle section, we take the data and then we go through some processing steps, and we use Amazon forecast to make the predictions of how that historical data will look like into the future. And then Amazon forecast takes the data, makes the processes the data, and then puts the predictions of that data into another S3 bucket that you can see down on the bottom right. So now this is an example of the architecture that we have and we're going to explore. So let's see, how did we make sure that this is architecturally well architected, or it has the well architected design. So let's refer back to the table that we had for the architecture best practices for the machine learning lens of the well architected framework. The first example that we had was cost optimization. So in the best practice, we're mentioning using managed services to reducing the cost. So why are we saying that? What is the reason behind using managed services? So when you are designing an architecture, when we were designing this architecture of this solution, we had the option of using some EC2 instances and running some open source forecast software. Or we had the option of running another EC2 instance to do the data processing for us. But then we decided that, okay, so if we use EC2 instances, we need to make sure that the security group, the VPC, the firewall, everything is set up correctly. And then if we use an open source forecasting application in that EC2 instance, then we need to make sure the software is patched. We need to maintain the software, and then every time there is an update, we need to push the update to the EC2 instances. So overall, it shifted the focus away from us, from doing what we wanted to do, which was building a machine learning applications, and it put a lot of maintenance and patching and security concerns instead of what we wanted to do, which is focusing on building a machine learning application. So instead of using custom EC2 instances and running the software in them, we decided to use AWS managed services. And the AWS managed services allow us to not worry about all the things that I mentioned earlier, for example, software patching, security, firewall, and all networking issues. And it allows us to just do what we want, which is building a machine learning application. So in this case, in this architecture, we decided to use a Lambda function to do the processing of the data. And then we decided to use Amazon Forecast, which is a managed service, to do the forecasting for us. And then in that case, we don't really need to worry about patching, security, or any of the issues that I mentioned earlier. So this is one of the examples that we used a best practice of the machine learning lens of the well-architected framework to reduce the cost of operation for us. So as I said, using managed services not only elevates your concern of security or maintaining or anything, at the same time, the best advantage of this best practice of using managed services is that it allows you to only pay for when you use these services. But in terms of EC2 instances, we had to shut them down when we were not using it, and we had to bring it up when we were using it. And at the same time, we had to make worry about auto scaling and scalability of the software and so on. But with the managed services, it takes care of auto scaling, and you only pay for when you're using the services. That means your costs will be reduced down to only when you use it, and then overall, if you compare the costs, you can see that your saving costs, your operation costs are going to be low, and you're saving money when you use managed services. Now, enough with the cost optimization. Let's go through other examples of the best practices. Before we go that, cost optimization has much more best practices than what the example that I just mentioned. You can look at them in the machine learning lens of the well-architected framework. I listed some of them here, but again, you can go and in detail review all of these examples and see how they can benefit your architectures. Now, to the second pillar of the well-architected framework, the second pillar is operational excellence. So here we listed two example best practices. One is versioning your machine learning inputs and outputs, and then the second one is automating machine learning deployment pipelines. So again, why did we mention versioning your machine learning inputs and outputs? So imagine when you have a solution that does a set of tasks automatically. So the reason that you have these automated is that you want to repeatedly do that. But when you have something automated does something from the start to finish, sometimes when you build something, it's not ideal, essentially. So what it means is that if you don't version your machine learning inputs and artifacts, when you're putting the inputs, the machine learning inputs, for example, you have a model, that model may not be accurate or may not generate the same outcome as you wanted it. So you want to revert back to the last version that was working stable. So, or when you have a model that was working okay, but you wanted to increase its performance, but then you made some changes, but it didn't make it more more optimized. It made it less optimized. So you want to revert back. So we were saying version your machine learning inputs and output artifacts so that if you want to revert back to earlier versions for any of the reasons that I mentioned, or any reason that I can't think of, you have the ability to do that. If you don't version your machine learning inputs and artifacts, in case if you want to revert back to earlier versions, it's going to be very difficult. And in some cases, it might be not even possible to do that. So it is a best practice to version your machine learning inputs and artifacts. And how did we do that? How did we apply this best practice into this architecture? Here you can see this highlighted S3 buckets. So the left-hand side bucket is where we put our inputs, machine learning inputs. So that bucket is configured to be a versioned bucket. So every time we put inputs, it creates a new version of that input, keeping the older versions on the bucket as well. And in the right-hand side bucket, where Amazon Forecast puts the outputs of the forecasting, that bucket is also versioned. That means every time Amazon Forecast makes a prediction, it puts a new versions of the outputs there, keeping the older versions in the bucket as well. So that if we want to revert back, we can just easily delete the latest version and then go back to the last version that we wanted to. Again, this was an example of applying a best practice from the machine learning lens into our architecture. And following the second best practice in the operational excellence, we had automating machine learning deployments, automating machine learning deployment pipelines. So for automating machine learning deployment pipelines, why do we say automate deployment pipelines? There are two reasons for that. One is automation, the deployment pipelines consist of a set of repetitive tasks. So if you have a set of repetitive tasks and if you don't automate it, that means it needs to be manual. That means a human needs to go there and do these set of repetitive tasks. But humans are prone to error, are vulnerable to error. That means if you have these manual tasks done by a human at every time, you can't really rely that every single time it will be done correctly. At the same time, if you give this task to a human, you cannot make sure that this set of tasks will be done all the time because a human cannot work 24/7 essentially. That would be not a human. A human, if we can work 24/7, is not really a human. But jokes aside, automating your machine learning deployment pipelines elevates a lot of the responsibility to an automated system. At the same time, it will ensure that the same set of tasks will be run every time you run that. And not to mention, it will make your life easier because automating pipelines is going to be much faster compared to manual. So how did we apply this best practice into this architecture? As you can see in the center of the architecture, we're using AWS Step Function. Step Function is a service that allows you to have a set of steps in a workflow defined that you can run, and it will automatically run step by step, and it will do the tasks that you configured it to do. So we use step functions to take the data, process the data, feed the data to Amazon Forecast, and then put the forecast outputs into an S3 bucket. This way, we're automating the machine learning deployment pipeline into our solution. And this is how we apply this best practice into this architecture. So operational excellence, as the other pillars in the machine learning lens, has more best practices. I listed some of them here, but you can see more of them by visiting the machine learning lens of the Well-Architected Framework. Now, down to our second example architecture that we want to talk about. The second example is another solution that we developed here at AWS that's called AWS MLOps Framework. So this solution, what it does is that it's a framework that allows you to create pipelines that automate the process of building and deploying and sharing your machine learning models. So it has two sections. In the left-hand section, it has the provisioning part. So when you provision this solution into your AWS account, it gives you two options to provision a pipeline. Option number one is calling an API, and option number two is committing a config file into a Git repository. Either way, it will call a Lambda function, and then that Lambda function will deploy a CloudFormation stack, and then that CloudFormation stack contains the pipeline that automates the building and deploying and sharing your machine learning applications. And then on the right-hand side is the pipeline stack that we call, or the provisioned pipeline. So this has it has an AWS code pipeline that has 4 main stages: the source stage, where the source assets of the pipeline are stored in an S3 bucket; the build stage that takes the assets and then creates a Docker container image around the assets and it stores it in Amazon ECR; and then in the deploy stage, Amazon SageMaker will take that container image and it will deploy it and create a model and create an endpoint onto SageMaker. And then in the share stage, we share that created SageMaker endpoint to the users by connecting an Amazon API Gateway API endpoint to the SageMaker endpoint that was created. This way, the user can send inference requests to API Gateway, and it will get to SageMaker endpoint and come back to the user. So this was the explanation of what this solution does, and let's explore how we applied architectural best practices onto this solution. So referring back to the table again, in the reliability pillar, we had a best practice that was called train once and deploy across environments. So what does this mean? It means that if you have a machine learning model, you only need to train it once. Once you make sure that the parameters are correct and set up correctly, and then you can use that trained model and deploy it across different environments. So how did we use this best practice? How did we apply this best practice into our solution? Let's see. So this is the solution. This is the architecture diagram of the solution, and you can see the right-hand side of the architecture is a deployment pipeline, and this deployment pipeline will take a trained model and then it will deploy it, build and deploy it and share it. What this means is that you do the training of a model separate outside of this pipeline, and then you only train it once, and then you can provision multiple pipelines using this solution into different environments. For example, if you have a dev environment, you have a pre-production environment and production environment, you have like 3 different environments. You can build 3 different pipelines and feed the once trained model into all 3 of these pipelines. And then you can deploy the same trained model across different environments. That means that you don't need to train your model in every environment that you have. And what that does for you is that it will save you cost, because training a model costs it will increase your cost if you want to train multiple times. And also it will give you confidence that the same model that is running in your dev environment or in your pre-production environment that you're running all sorts of tests, the same model is being run in your production environment. So that's why we say train once and deploy across environments, and that's how we applied that into this architecture. Again, reliability pillar has more examples of best practices. I listed a couple of them here, but you can look at the machine learning lens for Well-Architected Framework, and you can see more of them all in details with examples. And now the security pillar. So in the security pillar, we have a machine learning best practice of restrict access to machine learning services. So restricting access to machine learning services means that your machine learning services should not be exposed to the end user. And the reason for that is that, for example, if you have a machine learning service in the form of a SageMaker endpoint, and if you allow all the users to access that, it means that your machine learning endpoint is vulnerable to the users. And if you have, for example, if you're a small startup and you're not planning to have a lot of traffic, and you only have so much for your AWS budget, and then you expose a machine learning endpoint that is running on AWS to your end users, and suddenly you get a huge number of traffic towards that machine learning endpoint, that means your AWS bill is going to go above what you budgeted. And this is a not intended feature. That means your AWS SageMaker endpoint, now it's exposed to the clients or to your user base. So we advise of restricting your access to machine learning services so that you can control what comes in and accesses your machine learning services. So how did we achieve that into this architecture? So you can see here in the highlighted section, we put an Amazon API gateway in between the end user and the machine learning service that is SageMaker. So this way, if a user wants to access the SageMaker endpoint that we created, it needs to call an API gateway, and then the API gateway will re-forward or reroute the request to an AWS Lambda, and then the Lambda will call the SageMaker endpoint, and then we'll get the response back, and then pass it to API gateway, and then API gateway will send it back to the user. So now, if a user wants to access my SageMaker endpoint, they have to go through API gateway. And now API gateway has security features, it has IP blacklisting, it has request throttling so that I can restrict the access that my users have to my machine learning services. And again, security has more best practices, security pillar has more best practices, but you can see more of them in detail by visiting the machine learning lens of the well-architected framework. One of the examples is, for example, have ensuring data governance or enforcing regulatory compliance. As an example of like regulatory compliance is that if you have some form of data that's running in European service, Europe has some data regulations that you have to follow. So you need to ensure that you're following the regulations of data that you're running in your service. But if you want to see them more in details with examples, you can obviously visit the machine learning lens of the well-architected framework. Now we're down to the last best practice of the well-architected framework in machine learning lens. The last one is performance efficiency. So in performance efficiency, what you need to do is that the best practice is continuously monitor and measure the performance of your machine learning service. So what does that mean? That means that if you have a machine learning service, and it's running, you train the model and the model is deployed and it's running, users are accessing it, you need to continuously monitor how efficient the performance of that deployed model is. For example, when you train the model might have like 97% accuracy, but over time, because the new data that is coming, the trend is different, the model accuracy might go down to like 95% or even less than 90%. So you need to continuously monitor the performance of your deployed model to make sure that it has the accuracy that you intended for it to have. And if it doesn't have that accuracy, you need to gather new data, and then you need to retrain your data you need to retrain your model so that the model has the accuracy that you intended it. So how did we apply this monitoring and system performance of our machine learning services in this architecture? So this architecture, you can see we have an Amazon SageMaker. We're using a service called Amazon SageMaker, and we're using Amazon API Gateway. So in SageMaker, Amazon SageMaker has some features around model monitoring. So you can enable model monitoring within the SageMaker. We need to configure and customize your monitoring of the model that you deployed onto Amazon SageMaker. And you can monitor the performance of it, and you can even create alerts for it so that if the performance goes down, you get an alert notification. So by using Amazon SageMaker, we're allowing ourselves to monitor the performance. At the same time, using Amazon API Gateway, we can monitor the performance in terms of how many users are calling the service, and is our user base what we intended it. For example, are we getting 1,000 hits per day, or are we getting 100 hits per day, or are we getting like 5 hits per day? So we can monitor the performance of our system using these two services. And again, performance efficiency has more best practices. You can visit machine learning lens of the well-architected to see them in details. So that was all the best practices that we had to go through examples. Just to summarize what we went through in this talk, we compared taking software applications, regular software applications from development to production, and we compared them to machine learning applications, how different they are. We reviewed the AI ML services on AWS. We introduced machine learning lens of the well-architected framework, and then we went through examples of how to apply the well-architected best practices in AI ML architectures. I hope you had a takeaway from this presentation. I hope you learned something in this presentation. And the resources that I used for this presentation are listed here. So I'm going to take like a quick 2-second pause if you want to save any of these resources. Yeah, so the resources are listed are Well-Architected Framework, AWS Well-Architected Labs, Architecture Center, and AWS Solutions Library that contain a catalog of solutions that we have built and made sure they're all well architected. Thank you very much again for being with me in this talk. My name is Mohsen Ansari, again introducing, and thanks again. Have a great reInvent and have a good day. Thanks. Bye.